Welcome everybody in the lecture hall, welcome everybody on Zoom, welcome everybody from the future. So what's the menu for today? We are going to finish querying trees. Well, finish. We'll see if we finish, maybe I'll finish tomorrow, but we'll get deeper in JSONiq. Yep, so that's mostly going to keep us busy for the whole 2 hours. I have a few comments before that about the Docker and everything. So right now, the TA team is hard working preparing the exam, so the exam questions and so on, and also the exam environment, because actually it will be computer-based. And we hoped, by popular request of previous semesters, to upgrade to JupyterLab, because a lot of students had asked for it. Unfortunately, the digital exams team said that they do not support it yet because they need to run tests for security and so on first. So I'm afraid we'll have to still use Jupyter notebooks. So here's the current status with the Dockers. So the Dockers are basically an emulation of exam environments, right? The exam environment is not going to be Docker. It's going to be an actual Windows machine in something that's called the Safe Exam Browser. But the Docker is a simulation of that. So the Docker that we released v3 is very useful for you for the exercises because it has JupyterLab, it's more convenient, and it also has JSONiq syntax highlighting. Let me show you what it looks like. This one. No, that's not the one. This is the one. So this one has JSONiq syntax highlighting. It was actually a semester project by David Marian Buzatu, who graduated a few months ago. And so he implemented this for you, and now you can see the results. And this is available only on JupyterLab. So for the exercises, you could use this one if that works for you. And then we will release v4, that is the actual versions of the exam environments. But basically, it provides you with an alternative. If one of them doesn't work, then you can use the other. I heard of a few students who had trouble with the older Docker v2, and JupyterLab fixed the problems on their machines. So basically, we'll have the choice between v3 that has JupyterLab and syntax highlighting, or v4 that is the same as will be at the exam. If one doesn't work, then just try the other, and you will see. Okay. So this is what it looks like with JupyterLab. You basically have this additional navigation on the left, and this is what the syntax highlighting looks like in here. Something else that I would like to say is that we have here RumbleDB Sandbox. So there is this server that you might have seen at some places, this public.rumbledb.org. What is this? It's basically a bunch of machines that are on the Amazon cloud, very small machines, like 1 gigabyte of memory, just 1 core and so on, super, super small. But we put them out there for free and people can just run RumbleDB queries against them, right? So if you don't manage to connect locally to localhost to your own machine, then you can just replace it with public.rumbledb.org, and then it will send it to the public server. But for obvious reason, then you cannot read local files, right? You can only read files from HTTP, and so you need to use an HTTP URL whenever you open a file. All right, so I think this is pretty much it. Maybe I could also mention that page that is either with localhost or public.rumbledb.org, but if you do /public.html, that's kind of a debug mode that allows you to type a query here, click the button and get an answer, right? So it's just a test that the server actually works. All right, so just to get a feeling, who is successfully using the Docker? Okay, most of you. Who is still having problems with the Docker? Okay, so it seems to be very few of you. If you still have problems with the Docker, then keep reaching out to the TA team until we find a solution, or we really want to figure out even the tiniest problems with the Docker. All right, so let me now get back to the slides. Thank you for asking Zoom, Tobias. Always a good idea to check that everybody can hear. All right, so where were we? Well, the most important piece of information you need to remember for today is that every expression in JSONiq returns all at the same time, a sequence of items. That's the one thing you need to know. Once you get that, you will understand everything. Who actually run the tutorials that I've been doing at the beginning of the semester? Very good. So that was a request by your predecessors. Some of the students would have liked to have JSONiq spread a little bit over multiple weeks to make the learning smoother. If you haven't tried the tutorials, that's okay. Then now is the time to learn JSONiq. So everything is a sequence of items, and the items can be even heterogeneous, nested, so it doesn't have to be flat and homogeneous, right? Sequences of items. Now, if you have a sequence of one item, we consider that it's the same thing as the item itself. It's called the canonical identification in mathematics. It basically means we consider them the same thing. So if you say a sequence of one string, then it's the same as the string, right? We just flatten everything. And the flatten is also true for larger sequences. If you ever tried in JSONiq to nest sequences, like for example, here you would put a sequence of 2 items inside a bigger sequence, that's not going to work. It's just going to flatten everything every time, right? So sequence do not nest. They're always flat. And one particular sequence is the empty sequence, right? So you can have an empty sequence. You can have just one item, sequence of one item, or you can have multiple items. Now, what are the items you can have? Well, that should come as something natural to you because you've learned JSON and we've been through all the types. We have atomic items. So an item can be a string, an integer, a date, just atomic values. Or it can be an object or an object item, it's the same thing. Or it can be an array or an array item. Or it can be a function, but I'm not going to bother you with that. It's called higher order functions. Geeks love that. It's basically languages that can also take strings as values and return strings. We call that higher order functions. I'm not including them in the material. You don't need to worry about function items. But just know that there's been a super cool machine learning master's thesis a few years ago, where we actually figured out that function items are perfect for storing machine learning models, because then you can just call the model on a specific record and get a prediction. So the function items turn out to be really, really, really cool when you want to bring machine learning into JSONiq, right? Okay. So as I said, any expression in JSONiq takes sequences of items, returns sequences of items, right? So everything is a sequence of items, if you should. Put the door here. So everything takes a sequence of items and returns a sequence of items. Now, to give you the intuition of why sequences of items, why is it actually so powerful? It's so powerful because that covers the whole spectrum of heterogeneity, right? You can have sequences of items that are totally heterogeneous, like this is a sequence of 4 items. I'm displaying them vertically, but there is an integer, a Boolean, an object, and an array. That's a sequence of 4 items. It's both nested and heterogeneous, right? So that's, let's call it the maximum entropy you can get in the language, right? It's fully nested and heterogeneous. Then if you go a little bit to the left, it becomes a bit more structured. So here, for example, it's a bit more homogeneous because it's a sequence of arrays, and it's even a sequence of arrays of integers. It's a sequence of 4 arrays of integers here. Then here, you have a sequence of 4 objects, and these objects even have the same schema, right? So this is like not even nested because it's all flat, and it's homogeneous. Who here sees that this is actually a relational table? Awesome. How many columns? 2, yes. How many rows? 4, exactly. So this is perfect. So you see, what is the take-home message here is a sequence of items is more general than a relational table. Any relational table can be understood as a sequence of object items. But a sequence of items can be more general than that. It can be fully heterogeneous. It can even be a sequence of Booleans. It doesn't have to be structured. So this is a sequence of Booleans. This is a sequence of integers. This is a sequence of just one string, which is the same as one string. And this is the empty sequence, right? So this is the whole spectrum. And this is why sequences of items are so incredibly powerful. They cover relational tables. They cover single items, the emptiness, and they cover a huge mess, right, of plenty of non-related items. For whom is that clear? All right. And every expression is going to manipulate this, right? Very important. Okay, so let's get started with JSONiq. I think the best way to start with a language like this is where it also historically all started. In fact, it started with XML with something called XPath. But I'm not going to show you XPath. I'm going to show you how it works on JSON. XPath was basically to navigate XML, to go into the children of the elements and so on. But let's do it with JSON instead. So in JSONiq, you can open a file that contains one single JSON value, here a JSON object. It's a file, can be on multiple lines. It's not a JSON lines file. It's really just a JSON file, right? And you can just open it with JSON-doc, JSON-doc with the path in here. That path can be relative, like here, the file is just in the same directory. It can also be an absolute URL starting with HTTP, can also start with HDFS, with S3, depending on where you want to read it, can be absolutely anything, right? Then you can open it and you get what, when you open that file, a sequence of how many items? Just one object, that's it. Because it's a JSON file, contains one JSON value, one object item. So it's a sequence of one object, which is the same thing as one object. And you see it here, right? This is the one object. This is just one. Now, I'm going to add here dot countries. That shouldn't really surprise you because in JavaScript, in Java, in Python, in many languages, we navigate in objects with a dot, right? So if I say dot countries, that's going to navigate inside that object, the key countries, what's the value associated with it? That's this array. So how many items does that query return? One array item, just one. Now you probably itches and you want to extract what's inside, right? You want to basically open that array and get the 5 items that are inside. You can just use this syntax here that unboxes the array. And now it gives you a sequence of how many items? 5 items. And now you have a sequence of 5 objects, to be more precise. Okay? And then the syntax is powerful enough that you can continue navigating even though it's multiple items now. So if you say dot name, it's going to do it for every item. For every item that is an object, it's going to further navigate down. So now you get a sequence of 5 strings. Right? For whom is that all clear? Right? So it's magic, it just navigates in parallel. XPath was doing exactly that for XML. That is how it works for JSON. I could also do it with .code instead of .name. You see, it just nicely goes inside every object. And one more thing you can do is filtering. Think of the filter transformation in Spark, or think of the where clause in SQL. If you want to just filter some of the items that satisfy a predicate, then you just state what your predicate is. Here you want code to be CH, and that's only going to filter this one here. So that outputs a sequence of one object that is just this one, which is the same as the object itself. Now, a little comment here. In SQL, you would just write code equals CH, right, in the where clause, and that's it. But here, this $$ is basically just a placeholder for the current item that you're looking at. It's also called the context item. So this is a predicate that's going to be evaluated 5 times. 5 times. Once, so let me go back. So we evaluate it on it stops here, right? So this is the array countries that we unboxed getting 5 items. So this is basically this. And we evaluate the predicate, code equals CH, so $.code. Here, the predicate is going to return true because $, that's the object, .code, that's CH. equals CH, that's true. Here, $, the second time, $, is this, $, code is F, equals CH, that's false. Here it's false, here it's false, here it's false. Who is with me? All right, very good. So again, this $, it's the context item, and it's going to be bound to each item that's coming from the left. It might be now that what's coming from the left has 1 billion items. Then that's okay, you just get the $, bound to each one of these billion items. And every time this returns true, you keep it. Every time it returns false, you don't keep it. Who sees right now the use of lambda in the filter transformation of Spark? Because that's very similar. That's kind of the spirit, right? Except that here we don't have a lambda. It has to be $, the name of the item. Yes, we have a question over there. You can look at this. I just added .name. You can absolutely do that. It's like a gigantic Lego game. You can just assemble the queries like this in any way you want, and you can absolutely do that. And that is basically navigating now. This was basically just after the filter, after the predicate, you get this, and .name is going to get Switzerland. So that actually looks for the name of the country, the code of which is CH. That's what it does. Okay, who is with me? Very good. I'm going to accelerate if I feel that it's all that everybody's following. Now, this is a JSON file, one single JSON value, possibly spread over multiple lines. But there's another kind of file that we saw before. It's a JSON lines file. A JSON lines file has one value per line. Very often one object per line, right? But generally one value per line. So this is an example of JSON lines file that has 5 objects in one on each line. And so you see that if I call JSON file, it's a different function, right? JSON doc would be for a single JSON file. JSON file is really for a JSON lines file like this. If I stop here, how many items do I get? Yes, 5, exactly. These are the 5 items. And then if I do $, code equals CH, I'm filtering, I'm only keeping this one right here, and then .name gets me Switzerland. Who is with me? Right, very good. Okay, so this is JSON lines. By the way, we are discussing with Marco, who is doing his master's thesis with me, that this is maybe not the best name, and we are considering renaming it JSON lines to make it more intuitive, right? That's just a very old name that we gave 7 years ago when the first prototype was built. Okay. Now, given that, that's only the start. These are, so the dots lookup, the array unboxing, the predicate, these are only a few of the expressions. In total, I think we have 37 expressions like that. And you just assemble the 37 expressions like a Lego. So I'm going to show you plenty of screens like that have a query and the results. Very geeky, but it's good. We are all computer scientists here, just to drive you through the language. So I told you in JSON file, you can also put a URL, right? It's going to work. RumbleDB is going to download it from the web. It's going to connect and download that file. I think this actually exists. You can really use that. We actually did put a JSON file in there. So that should normally work. So if you do that, JSON file, that's a JSON lines file here, and it's going to output a gigantic sequence, because that's actually a very large file. And in fact, it has 36,000 items, right, in that file. So now you see, it's just because it doesn't want to crash your computer. RumbleDB is very nice to use. So instead of crashing your computer with potentially billions of items, it tells you, okay, that's more than 200. So it's more than 200. I'm going to stop there with a little warning that there's more, right? But it's not going to display all of them in here, right? So it's just for convenience. Okay, so this is just returning technically a sequence of 36,577 objects. Okay, then I can do things like this in another expression. This extracts the item at a specific position, starting with 1. So if I say square bracket 1, that's basically extracting the first item. So here I see just one object. It's a very large object, right? But this is one object, and that's the first object that there is in this file over there. You might have noticed that technically it's the same syntax as the predicate, right? Because here you have something in square brackets, and here you also have something in square brackets, right? So it is indeed the same syntax. What you need to understand is that the way it works is it depends if that's a Boolean or an integer. Here it's going to be a Boolean. So what it's going to do is it's going to evaluate to true and false and keep it if it's true. But if it doesn't evaluate to a Boolean, but it evaluates to a number, like an integer here, then instead it's going to look for a position, right? So 1, then it returns the first object. If that were 10, then it would return the 10th object. Who is with me? Who is with me? Awesome, perfect. I saw a question over there. Yes, absolutely. Evaluates too. So very often, I mean, in 80% of the cases, you actually have an integer literal, but that would also work if instead you would put a sum or some more complex expression. You could even have in there an expression that is 1,000 lines, as long as it evaluates to an integer or a Boolean. That's the idea. It's a Lego game again. Yes?
Can you nest these? So can you put an accessory to another value inside one of those expressions that evaluates to an integer?
Yes, absolutely. You can put whatever you want in there that evaluates to an integer. You can nest. Oh, oops. Are you okay? Are you okay? Yeah? All right. So again, it's a Lego game. Whenever you expect an integer or a string or an object or whatever, you can always put an expression instead that evaluates to an integer or an object and so on. Okay? Good. There's another question. Yes?
I was wondering, when we have those expressions that evaluate to Booleans, we can check over all elements in the sequence. Can we also have a indexing by a sequence of integers?
Pandas, right?
The whole data set?
Like pandas or something like this.
Yes.
Yeah. So no, here it doesn't exist. That's really either Boolean or integer. In fact, if you think about it, it's simpler than pandas, because for a computer scientist, you can explain it's a sequence of Booleans, and then you keep those that are true and so on. But for a non-computer scientist, it's not very intuitive to do this. So instead, the paradigm is slightly different. Instead of putting in here something that evaluates to a sequence of Booleans of the same length as the original sequence, you do something much simpler. You just take it one at a time. You take one item, you evaluate it, it's true or false. It's much easier to understand for a non-computer scientist. Does it make sense? All right, so, okay, so now we have a function called keys. This function can take a very large sequence of whatever, and it's going to look at the objects in that sequence, and it's going to output all the keys, but the distinct ones. It's not going to repeat them if they appear at plenty of places. So here, if we do it on that data set, that allows us to discover the data set, to discover the schema, and even though it has a lot of objects, it tells me right away that there's eight strings in there. Okay, 8 keys, sorry, 8 different keys. So that means that if you look at it, that's kind of a data frame with 8 columns, right? You could view it in that way. Now, what I can already tell you here, and I've already told you before, is that if you use it on a JSON lines file that could have billions of rows, that's going to take a while to do because it needs to look at all the objects. With the power of Spark, because there's actually Spark behind, it's not going to be so much time because it's going to be able to do it in parallel, but it still needs to look at all the objects. Who realizes that if instead of a JSON lines file, I had a Parquet file, and that's literally just writing Parquet file instead of JSON file and then something.parquet, who agrees that that would be immediate? Very good. And it's immediate because in the Parquet file, the schema is stored at the beginning. So you just look at the schema and that's it. You don't even need to read the entire Parquet file, right? So this is magic, but the query is the same. It's exactly the same pattern for the query. You just use the keys function.
Does this work for nested keys, or is just the top level?
Just the top level keys. Yeah, for the nested keys, you can also use some other queries. You can write a more elaborate query that would recursively figure out the keys. This one just looks at the top level, right? Okay. Then that's, so this is not new, right? So here what I'm doing is I'm opening the file and I'm navigating to dot type. And here I'm basically receiving 36,000 strings in there, which are basically all the values associated with type in every object, right? So this is not new, I explained, right? It's a parallel navigation. We just look up the value associated with the key type for every object that there is coming from that file. Now, if I'm interested in understanding my data set, right? Imagine it's a data set you freshly downloaded from the internet and you're trying to make sense of it or analyze it. Then you probably want to know what are the distinct values of type. So you have a function for that called distinct values, and that is going to return all of the distinct strings that you have in there, right? So very convenient for discovering data. Okay. We also have a count function. The count function can be called on pretty much anything that returns a sequence, but we know that every expression returns a sequence of items, and counts just returns one integer that is the total number of items in the input sequence. Okay, so here we have, it's a small one to keep it, oh no, sorry, that's because we have created at, so there's a bit of a filter here. So we look at the data set, we navigate to created at, we look at the distinct values, and we count the total number of distinct values that are associated with created at, right? Who is with me? Okay, you have a question?
When we pass an array that is basically a sequence containing an array, does it return one or the length of
One.
the array?
One. An array is just one item.
And is there a way to find the length of an array too?
Yes, absolutely. You can use this unboxing with the square brackets, and then you put it in count. It's a Lego game, so you can do that. You unbox the array and then call count. Then you have the total number of items. There is also a function that is called size, and that would also directly return the size of the array. But even if it didn't exist, we could just use count and array unboxing. Okay. So you see, these are not expressions, these are just functions. And there's a very big function library. These are all standard functions coming from the W3C for the most part, and a few of, so these are all from the W3C, it's all coming from the international standard. Some of them are specific to JSONiq. These are the ones that deal with JSON, like keys, for example, is specific to JSONiq. And distinct values and counts, these are all standard functions. Okay? If I remove these distinct values and created at, now I'm counting the size of the collection, right? Now you have to imagine this is small. This actually fits on your laptop. You could have that file here, it's on over the web, which is why it still works, because you can just download the file from the web. Now, if you want to do it on something bigger, then first you should no longer use the web, because you cannot just download a gigabyte every time you do the query. So then you download it to your laptop, and then you can call that function on your laptop, right? So for example, here, once you've downloaded it and stored it on your laptop as a relative path, then you can directly count 206,978 items. That's a bigger version of the data set. What's important to understand is that here, when you look at the query, it's the same query as here, right? It's always count of something. But there is magic happening, because in fact, that file is going to be in memory automatically put inside an RDD in Spark. It's going to be an RDD of the objects. And this count is in fact pushed down, remember the word pushed down to Spark. What RumbleDB is actually doing is creating an RDD and then using counts directly on the RDD of objects. So this is why this query is in fact going to be faster than an iteration would be, right? Because it's directly using your computer cores, even on a single laptop. It's going to spread it over the cores, add in every partition, count the number of objects, and then do a simple addition, right? But this is handled by Spark. But the nice thing is that whoever writes this query doesn't even know that Spark exists. It's all hidden and out of sight, right? For whom does that make sense? right? That's the power of data independence. We have a model with sequences of items, and expressions that return sequences of items. That is all the user needs to see. All the rest, RDDs, data frames, and so on, this is all hidden. Okay, but I'll come back to that. What if you want even more data? So the GitHub archive data set is actually so big that you have one file per hour, and it keeps generating new files that that are taken out of the activities on GitHub. And so it's actually absolutely gigantic. So at some point, your laptop is going to run out of space, and you can just no longer use your laptop. So what do? Well, you just go to Amazon or Azure or Google Cloud, you click a few buttons, span a cluster with a few machines, and then you let's say you have HDFS, then you just put the files on your HDFS cluster. Or if you don't want to bother with HDFS and you want to keep it in the long term, then use S3, right? So you could download these files and put them on S3, and then you can access them using an S3 URL. So here I put a relative path, assuming we're already connected to the cluster on HDFS and so on. But that can also be an absolute URL with S3 or whatever. And now the magic happens is that this count, it's exactly the same query. It's exactly the same query as before, right? The only thing that changed is the size of the file. And now it's returning, I need to count the number of digits because it's so many, it's like 2 billion. And the time it took, I actually did it. This is a real evaluation that I did on an Amazon cluster, and it returned in just a few seconds. And again, that is because there is Spark on the cluster, and RumbleDB is actually compiling JSONiq to Spark. And this is why we get the result quite rapidly, but it's all transparent to the user. Okay. Let's use another thing that we've seen. Imagine I use now a predicate. I basically have this large collection of 2 billion objects, and I want to only see those whose type is a push event. That's basically a filter, a where clause in SQL. I can use the syntax you know, and that's going to return all of the objects that match this predicate, okay? There is nothing new on that side. I'm just assembling expressions you already know, right? The JSON file call and the predicate expression, okay? Who is with me? Very good. So let me continue. Okay, so let's make a small break on all these geeky screens. And so far we've navigated. So the use case is we have a data set that we take from the internet. We want to discover it. So we look at the keys, we look at the distinct values, we count the number of distinct values, we count the number of objects in the file and so on and so on. But this is only one aspect of JSONiq. In JSONiq, you can also just create new items out of nowhere. This is called construction, just like constructors in Java or C and so on. So now I have really great news for you, is that whenever you want to construct something that is basically a JSON value, like a string, a number, a Boolean, a null, or an object or an array, great news for you, you literally copy-paste the JSON inside your notebook, and that's a JSONiq query. Right? That was one of the core ideas of the design. JSONiq must be a superset of JSON. So any JSON value that you paste as a string, that you copy paste as a string, that is a serialized JSON value, any JSON value returns itself. You see it as a JSONiq query. So that here is a query that returns the string foo. These are 3 queries that returns these 3 strings. It's exactly the same syntax as JSON, including the backslashes and so on, right? You literally copy paste JSON. These are 3 queries that also return themselves, right? These are well-formed JSON values, right? Now, just to explain a bit more what actually happens when you actually build these values, you know that in JSON, there's just numbers, right? But we saw in the schema validation part that we can have a huge type system with all kinds of number types, right? And so we've seen them, right? Integer, decimal, double, and so on. And in fact, that's exactly how RumbleDB is going to do it. If you don't have any dot or any exponent, it's just going to return an atomic item of the type integer. If it has a dot, but there is no scientific notation, and by the way, you can have absolutely any number of digits here, even 1,000 digits if you want, then it's going to create a decimal value. And if you have a scientific notation, you know, the E is times 10 to the power of, then it's going to create a double value, right? The IEEE 754 standard, the floating point standard. Okay, so here, depending on the literal that you have for the JSON number, it's going to return one of these three in here. But the rule is still valid that you can copy paste the JSON number in there. It's going to evaluate to itself with the appropriate type. Booleans, the same. You put true, you put false, they evaluate to themselves. You get the Boolean true and the Boolean false. Now, what if you want some other types that are not native to JSON? Then you just use constructors. You use the name of the type, long, in, short, byte, and you just pass a literal value as a string, right? Non-negative integer, date, time, date timestamp, G year, G month, G year month, like all of these types that you see in here. You remember these Star Wars-like strings, like with 1 day, 2 hours. Here we have 1 year, 3 months, and 3 days, and so on. So here it's a base 64 string. So that's an encoding. That's an encoding of a sequence of bytes. But base 64 is this. You probably know it from HTTP. And here in the hexadecimal format with base 16. Okay. So this is how it works. Just use the name of the type and pass a literal or a lexical value as a string, and it's going to construct that value. Yes?
On the previous slide, why do we have dashes for the G day, I think it was?
Yes, so these are really advanced. I put them in there for completeness because they exist. It's part of also the standard of W3C, XML schema. What they mean is this is this is the month of November. This is the year 29. Why am I operating and disapparating the whole time? Anyway, year month, basically November 2019 in here. And here you have a month and a day. So this is November 26 plus potentially a time zone. And here you just have a day. So it's 26. Why the dashes? I have absolutely no idea. That's just the standard. It's the ISO 8601 standard, and it's defined in that way, right? It's always a good idea to follow a standard. If you ever need to output a month and a day or something like that, instead of cooking your own thing, try to follow a standard, because then this is how other processors are going to be able to parse it. Okay, did I answer your question? Yeah, okay. Okay, let me continue. Okay, so this is for supporting all of the types that are not native in JSON, right? You can just construct them in this way. What if I want to construct objects and arrays? Exactly the same thing, copy paste them. You agree this is JSON, right? This is well-formed JSON. This is also a JSONiq query. What does it return? Itself. It returns an array that has 2 objects and so on. Plain and simple, copy paste, and that's it. Now, what if you want a sequence? Well, you use commas. You just separate your values with comma. I really need to say values. It's values, key values, and so on. I'm trying to take the habit. So you separate your values with commas, like this is an array followed by a Boolean, followed by a string, followed by an object, and that returns a sequence of how many items? 4, exactly, 4 items. And it's a heterogeneous sequence, as you can see, because these are not items of the same kind, but that's totally fine. You can absolutely do that, right? That would be unthinkable in SQL, something like that. Okay, what if you want a shortcut to directly build a very large sequence of increasing integers? You actually have that in Python and many other languages too. Just use the to expression. 1 to 100 returns a sequence of how many items? 100, right? It's going to return all integers between 1 and 100. Okay. So is there a question? No questions? Okay. So these are all the ways you construct items, atomic items, objects, arrays, these additional built-in atomic types, and sequences of items. So now you know how to navigate, and you know how to build new items and new sequences of items. Okay. Who is with me? Okay, so let's continue then. What you also have in a language, and here I'm going to go very quickly because you know that, it's the arithmetics, right? So for example, you have addition, subtraction, multiplication, division, careful, not a slash, div, integer division, idiv, and modulo. Idiv and mod, so these two basically give you a Euclidean division. Who heard of Euclidean division? Right? Okay, very good. So these are all quite standard, and you have arithmetics. But you need to be aware of one thing, is that normally in most languages like Java, Python, and so on, these languages always have one value. Everything returns one value. But here we have sequences. The sequences can be empty, or they can have more than one item. So the problem is that what's on the left of the plus and on the right of the plus doesn't need to be one item. It could be empty or it could be more than one. So it means that JSONiq also needs to tell you what happens if that's the case. So now, if you have something that's empty on the left or on the right of one of these arithmetic operations, then you just return the empty sequence, right? It's going to work. It's not an error, but you return the empty sequence, right? So empty sequence plus 1 returns the empty sequence. A string plus 2 returns an error. There is no overloading like in Java where you can reuse the plus and it automatically figures it out. So we don't use plus for string concatenation, right? That's an error. You cannot add in a numeric sense a string with 2. That's an error. If what is on either side returns a sequence of more than one item, in that case, 2 items, 3 and 4, that's also an error. You cannot do that, right? So it's either 0 items or 1 item. 0 item, you return the empty sequence. 1 item, then you add them. Okay, who is with me? Very good. Now, now you might ask, okay, how do you do string concatenation then? Well, you use the same as in SQL, the double vertical bar. That's how you concatenate strings. But you also have plenty of these standardized strings. They all come also from a W3C standard. So you can concatenate with the concat function. You can use string join to concatenate these, but you put a dash in between. You know, like in Introduction to Programming, this is one of the first things you do. You know that this is not easy to implement because you need to have a for loop, but special casing the last one, right? Do not add a dash at the end. But with a functional language, it's nice because you just do it functionally, right? So you just say, this is the sequence I want to join, and this is the separator that I want to have in between, right? So that's going to return foo dash bar dash foo bar. And then you have substring, string length, and so on, and so on, and so on, and so on. There's a very, very large library of functions that is available, right? And they're all in the JSONiq, in the RumbleDB documentation. Normally, we did a list over there. Okay, so arithmetics, string operations. Then we also have greater than, lower than, and so on, right? So I don't need to say much about this, right? That works like in any other language. Except that, again, it doesn't have to be just one value. Could be 0, could be more. So we need to say a few words about that. So they evaluate 2 Booleans, right? So the first thing is that if you try to compare a string with an integer, it's not like MongoDB. You remember, MongoDB is not going to complain. It just has this arbitrary way of sorting them. Not so here. You cannot compare a string with an integer. That's an error. Now, what happens if there's a sequence of more than one item, right? For addition and arithmetics, that was an error. For comparisons, we don't actually throw an error. We do something that's actually very useful for many use cases. We do I'm going to throw that at you. We do an existential quantification. What do I mean with existential quantification? I just do the comparisons for all the numbers in here. And if at least one succeeds, then that's true. So if I say all of that equals 1, it's true because at least one of them is equal to 1. Okay, for whom is that clear? So it's very convenient because that's a shortcut. If you have a very large sequence to directly test if it contains a value, you can just use the equal sign and that takes care of the job. You don't need to iterate or anything. Here, it's if both sides have more than 1, again, it's existential. You need at least 1 on the left and 1 on the right that compare in the way you want. So here, 1 is smaller than 3. That's enough to return true. Do we have a question? Okay. Okay. So we have the break actually now. It always rings when I'm in the middle of speaking anyway, but I might as well stop before. and let you go. I'm going to grab a cup of coffee. So I'll see you in 15 minutes. Then we'll continue the journey through JSONiq. Thank you.